Hello guys, welcome to Cognos Education, and today we're going to be starting AP Calculus AB/BC Unit 1, Lesson 1, Intro to Limits. So, with this course, I'm going to be a little more fast-paced and have less of the definitions since I'm assuming you guys already have a good foundation of algebra and basic geometry. So, we're going to start calculus by talking about limits. So what exactly is a limit? So let me get a graph. Okay. So limit, that's an extremely small graph. Let me zoom in. I don't think I can, but let me get a bigger graph. My bad. So, yep, that's about as big as we're gonna get it here. Yep, that's better. Here it is. So sorry. Just skip this part. I'm struggling badly on getting you guys a good reference. I'll draw my own graph at this point. Okay, so let's say we have the graph. Graph of y over x of this parabola. And you probably talked about parabolas in Algebra 1. So we know that these two are the roots. So this is at x equals 2. This is at x equals 4. This one's at 3. So limits don't talk about the value of a function. It might seem like they do, but they're asking what value do you approach as the function and gets infinitely close to a number such as x equals 3. And they're defined in this notation. So the limit as x approaches 3. And this is of x minus 2 times x minus 4. So in cases like these, you can most of the time just plug in the number because that'll give you the value it's approaching, right? So 3 minus 2, that's 1 times. So I'm not sure what I did. Oh, yeah, I see what I did. Yeah, my graph's pretty wrong, but just imagine that this is a new equation and it has nothing to do with the graph. Uh, 1 times -1. So the limit as we approach 3 is -1. So that's pretty basic. Now, sometimes you're gonna have graphs with, let's say, asymptotes. No, not holes. Yeah, where the graph isn't defined. So let's say, for example, here at 3, 2. What's the limit as the function? Limit as x approaches 3 of that function. Well, you might think, oh, it's undefined. The point at that point is undefined. But let's look at this graph. For a limit to be defined, it has to be continuous over that interval. Well, how I like to think of that is that I could draw this graph over that interval without lifting my pencil up off the paper. Like if it wasn't continuous, we'd have something like ch, and then and there's just empty space here, or like an infinite. discontinuity, where it just jumps straight to infinity. So let's see, when we see this, what is it approaching from both sides here? As we go up, it gets closer and closer to 2. I mean, if you plug in 2.999, that's approaching 3. It's going to be really near 2. And if you plug in 3.00001, that's also really close to 3. We can see it'll be like also 2. So this would just be 2. Even though the function isn't defined at that point, it's approaching a value at that point. And this works for, I think it was piecewise functions. Yep, you can have a piecewise function with like something like this, and then it just jumps off. You have whole, and then like that. It can still be defined at this point. It's continuous over that interval. Can, but let's see. It cannot be defined at this point because look, even though that's one point, we're approaching two different values from the point. We're approaching this value, and they're completely different. We'll get into those later. They're called left and right-sided limits. So this limit we will write does not exist. So the limit of 1 over x as x approaches 0, we can have, oh, what was the graph of 1 over x? Let me pull up Desmos. Yeah, okay. So we have something like, we have to draw. So it goes like, and then it does the same thing on that side, I think. Something like that, yeah. So the question is, does this limit exist? Well, let's see. What's it approaching from this side? It looks like it's approaching negative infinity as x gets smaller and smaller, but it's still negative. So negative 0.00001. This is gonna become infinity because you're dividing by extremely small numbers, so it goes into it a lot of times, but it's negative, so it's gonna be approaching negative infinity. But this side, it's positive. It's approaching positive infinity. We have two different limits from two different sides, so it does not exist. And then so pretty much the limit is the value of function approaches at a point, which most of the time is the value of that point, but not always. We will get into that later. So now we'll do a couple practice questions and maybe clear up things I haven't explained yet. So we're gonna start with this question pulled out of Khan Academy. Okay, the value of a function h is defined over the real numbers. This table gives us a value of h. So it says that this function is defined for real numbers, so that's a good thing. So what is a reasonable estimate for the limit as x approaches -6 of h of x? So it gives us this chart so we can see this would be -6 right here, somewhere here. But we have two values very close to it, -1.02 and -0.98. So I think you can tell just by looking like this at this, it approaches -1. It's like decreasing. it's increasing, and then it's increasing again. So this imaginary, this um, this placeholder would probably be -1. So our answer is -1. That is right. Okay, another example. This is what we talked about. So function f is defined for all real numbers except x equals 3. What is a reasonable limit as x approaches 3 of f of x? It's not defined there, but does that mean it's not approaching a value there? No, it is approaching a value there, so we can still find the limit. So as x approaches 3, we're approaching -4 from this side, -4 from that side. Another way to just tell that it's approaching the same limit from both sides is, does it do some crazy thing like this, or does it just continue? If it continues, then it's approaching the same limit from both sides. So this would be -4. Okay, now we have something different. I most likely should have talked about this. What is the limit as x approaches -5? So when we look at this, you most likely will think that, oh, look at it. It's defined at x equals -5. So it has to be 6 because it's literally defined at that point. The value is 6. But limits don't talk about value. This is the one point where just plugging in the answer will not work. It'll give you 6, but that's not the limit. Let's see. From the right side, it's approaching what, -4. From this side, it's approaching 6. It's approaching two different numbers, two different sides on the same point. That means the limit does not exist. Okay. Now we'll have another table problem. I encourage you to try this one by yourself because we did one like this. So pause the video, try it. Okay, let's continue. So what's a reasonable estimate for the limit as g of x approaches -2? So we can see these are closest to -2. And it looks like it's decreasing. There's a placeholder here where g of -2 is, and it starts increasing. So it'd probably decrease to 8. It looks like that's literally the closest number. And then it started increasing. So answer would be C. And one last problem that I encourage you also to try out. Okay. So what's a reasonable estimate for the limit as x approaches -4 of g of x? Try this out. Okay. So I'm gonna go faster on this one. We can literally see we're approaching two different values from two different sides. So the limit does not exist. And that was lesson 1, Intro to Limits. Thank you for watching the video.